Welcome back. We're looking at this function, which is a transformation of a basic exponential function. Now, I've called some of the things differently. Go ahead and write this equation down. So pause it, write it down. Have you written it down? Good. M is the thing we were calling A. We're not going to call it A anymore. We're calling the coefficient in front of B. That's what we're calling A. So in other words, in this function right here, B is this 2, so B is this 2, and A is the 3 now. That's what we're calling A. That's 3. M is the thing that we were calling A. M is the thing that kind of makes it go. So look at this red one. So it's making it get narrower and wider, and when it gets negative, it flips it this way. And when it's positive, it orients this way. Good. So we'll leave that there. And I wanted just to show this 3 to the 2 times 2 to the x to illustrate what the A is. It's the 3, and what the B is. It's the 2. Now let's move on and look in general at what happens with this function when we change the coefficient, when we change A. Now again, you already know that B also makes it get steeper and wider, and when B is a fraction, so notice that would be between 0 and 1. So it's just getting narrower and narrower and narrower and narrower, and now it's a fraction. And notice what happened. When it became a fraction, it flipped it over. It was facing like this, but as a fraction, it orients this way. Orients this way. I'm going to leave it just like that, and we're going to continue to look at the different components. Remember, K simply moves the function up, and it moves the function down. So it moves the function up, and it moves the function down. So here I have A is 4. What does A do? Well, A, let's just see. It's probably moving it a little bit too fast. Let's try that again. So I'll slow this down. So when A is negative, it flips it over the x-axis. When it's positive, it flips it this way. It makes it orient upwards. And when it gets larger, it makes the function steeper. When it gets smaller, it's stretching it out. And then negative, it makes the function face downward. So it's facing downwards. Watch this. Now it's positive, so it faces upwards. So that's what A does. It changes whether it reflects above or below the asymptote. Notice what I said. It changes whether it reflects above or below the asymptote. And since I'm bringing up asymptote, it means we really need to look at asymptote and this thing that we call the intercept. So I'm going to let A equal 2. So it means it's like 2 times whatever B is, which is 3. So 2 times 3 to the x plus K. And here K is 0. Let's change K now to a negative 3. So two things are going to change. A and K affect the intercept. So the intercept here, the y-intercept, is at a negative 1. A negative 1. Well, that's because I said A plus K. Let me write that for you. So y equals A plus K. So the coefficient in front plus the K. That would be 2 plus a negative 3, which is 2 minus 3, which is a negative 1. And that's just what we found. So the new intercept is at A plus K. However, The asymptote, the new asymptote, is at just y equal to k. So look at that, it's at y equal to k. I'm going to press play again and watch what this A does. It's above the asymptote, above the asymptote, it's above the asymptote, and now it's negative, so it's below the asymptote. It's below the asymptote. Let's change the A a couple more times. So I'm going to say that A is 2. I'm going to say that K is 10. Let's look at what's happening. Here is our asymptote at y equal to k, and our intercept should be at 10 plus 2, which is 12, and that's just where it is, at 12. Let's play around with it one more time. Say A is a negative 4. We'll say that y is 1/2. Y is 1/2. Or k is 1/2. There we go. That would make it work. So here we are. A is a negative 4, and k is 1/2. So our asymptote is at y equal to 0.5, and our intercept should be at a negative 4 plus 0.5. That would be a negative 3.5. And let's see if that's what we get. Yep, a negative 3.5. There are 4 functions now that you'll be able to sketch, and the things that you want to keep in mind are, where's the asymptote, what is the y-intercept, and then this. Watch. Does the function open like this? Does it open like this? Does it open like this? Or does it open like this? These are all things you know how to do now based on the skills you've learned in this video and the one right before it. So sketch G, J, H, and I, and then I'm going to slowly reveal them so that you can check your work. Remember, pause, notate the asymptote, the intercept, and the general form of the graph that looks like this, like this, like this, or like this, and then check your work. We'll start with g of x. Once you've sketched g of x, press play. So here we have the y-intercept is going to be at 4 minus 3 at 1, which is just where it is. And we have the asymptote at y equal to 4. Y equal to 4. When you're ready, press play. So here we have, it's opening like this. And we have our asymptote at y equal to 2.5. And we have our intercept at 2.5 plus 1/2, which is 2.5 plus 0.5, which is 3. When you're ready, press play. Here we have our asymptote at y equal to negative 3, and our intercept at a negative 3 plus 2, which is a negative 1. And it's opening in this direction. When you're ready to move on to the next one, press play. And here we have our asymptote at y equal to 1, and our intercept at a negative 4 plus 1, which is a negative 3. There's another video that we posted for tomorrow as well, so make sure to watch that one as too. You can go back and rewatch this if you need practice on these last 4 equations. See you tomorrow.